So today the topic for discussion is the miscellaneous examples on the chapter interpolation, and we are going to cover examples, mixed examples on the previous three methods, that is Newton's forward difference method, Newton backward difference method, and Lagrange's method. That is the three formulas: Newton's forward interpolation formula, Newton's backward interpolation formula, and Lagrange's interpolation formula. So the first problem is on the Lagrange's interpolation formula. What is the problem? Using Lagrange's interpolation formula, fit a polynomial to the data and find f3. Then find f3 by using that polynomial. So first we have to fit the polynomial to this data. That is, we have to find the function value of y or fx, such that if we substitute x as 0 in that polynomial, we get the answer minus 12. Similarly, if we substitute x is equal to 1, then we get the answer 0. So we have to find the such a polynomial that fits to this data. So here these values of x are what? x0, x1, x2, x3, and the values of y corresponding to these x0, x1, x2, x3 are what? F of x0, f of x1, f of x0 is minus 12. That is the value at x0. So right here y x0 or f of x0, then f of x1, f of x2, f of x3. These are the values of f of x0, f of x1, f of x2, f of x3. And then write the Lagrange's interpolation formula. So what is the Lagrange's interpolation formula? Fx is equal to x minus, here the values of x are 4 in numbers, 1, 2, 3, 4. And the values of y are also in 4 in number, 1, this is 2, 3, 4. And therefore we have 4 terms. And what are that? The first term is x minus x1, x minus x2, x minus x3 divided by, that is in this numerator there is no x minus x0 bracket term. Okay, so in this numerator there is no x minus x1. In this numerator there is no x minus x2 term. And in this numerator there is no x minus x4 term. So what is the numerator? X minus x1, x minus x2, x minus x3. X minus x0 is missing. And then x0 minus x1, replace only this x by x0. So what is the denominator? x0 minus x1, x0 minus x2, x0 minus x3, f of x0. So this is the first term. Then what is the second term? Write numerator as x minus x0, and the x minus x1 term is missing, delete that term, and then x minus x2, x minus x3, because there are only values up to x3. If there is another value of suppose there is extra column, fifth column is there in this table, then write the next term x minus x4. Here is also write x minus x4. So here the last term is x3, therefore write here x minus x3, and then just replace x by x1, because what is the term, missing term? What is the bracket after x minus x0 is x minus x1, and x minus x1 is deleting from this numerator, and therefore write here x1. Here is x0, then x2, x3. So what is the term, missing term here? Delete the term that x minus x2. What are the numerator? What is the numerator? X minus x0, x minus x1, x minus x3 divided by x2 minus x0. X2 minus, just write here x as x2. X2 minus x0, x2 minus x1, x2 minus x3 into f of x2. Similarly, the last term x minus x0, x minus x1, x minus x2, and x minus x3 is missing. Delete that term, and then x3 minus x0. Just write this x as x3 into f of x3. So this is the Lagrange's interpolation formula. If this these values of x are 5 in numbers, then we have the 5 terms in Lagrange's interpolation formula. If these the values of x or y are 3 in number, then we have 3 terms. And what are these terms? So here the values of x or y are 4 in number, and therefore we have these 4 terms. And in the first term, x minus x0 deleted. In the second term, x minus x1 deleted. In the third term, x minus x2 deleted. And in the last term, x minus x3 deleted. Okay, and then substitute just the values. So what is the value of x? in this problem we have to fit the polynomial, we have to find the polynomial which takes these values, and therefore just write x as x. If we had to interpolate by using Lagrange's interpolation formula, that is, if I had to find suppose value at 3, the value at 3 is not given in table of y. The value of y at 3, we have to find the value of y or fx at 3. Then substitute x as 3. But here we have to find the polynomial which takes these values. Okay, and therefore write x is equal to x. Similarly, if we are going to use the Newton's forward interpolation formula, Newton's backward interpolation formula for fitting a polynomial, then also substitute x is equal to x. Here, these values of x are not equidistant. This distance between 0 and 1 is 1. The distance between 1 and 2 is 1. But the distance between 2 and 4 is not 1. That is, the values of x are not equidistant, and therefore the Newton's forward interpolation formula and Newton's backward interpolation formula is not applicable to this example. So here just the question is of this form, that this is not given, that using Lagrange's interpolation formula, this is not given. Suppose the question is started from, suppose here, that fit a polynomial to the following data. So in order to fitting a polynomial to data, we are going to use the Lagrange's interpolation formula, Newton's forward interpolation formula, Newton's backward interpolation formula. But if the values of x are not equidistant, then we have to use the Lagrange's interpolation formula. We cannot use Newton's forward or Newton's backward. But if the values of x are equidistant, the values of x are equidistant, and we have to fit the polynomial to the data, then the instructions like this, using Lagrange's, using Newton's forward interpolation formula, this is not given in the problem. Then we can use any one out of the three, that is Newton forward, Newton backward, Newton or Lagrange's, when if the values of x are equidistant. But if the values of x are not equidistant, then we have to use only Lagrange's interpolation formula. We cannot use Newton's forward or Newton's backward interpolation formula. When we use the Newton's forward and Newton's backward, if the values are equidistant. So remember these things, that Newton's forward, backward are applicable if the values of x are equidistant. So substitute the values of x as x, and all these values x1, x2, x3, x0, substitute all the values, and the f of x0 is minus 12. So we have this answer, 1 by 2 x cube minus 9x square plus 32x minus 24, and this is the cubic polynomial which fits to this data. That is, if we substitute in this polynomial, if we substitute x as 0 in this polynomial, then we get minus 12 answer. If we substitute x is equal to 1 in this polynomial, in this answer, that is, substitute x is equal to 1, 1 cube is 1, minus 9, 1 square is 1, and then 32 into 1. So if we add and subtract all these numbers, we get answer 0. If we substitute x is equal to 2, then we get the answer 6. If we substitute x is equal to 4 in this polynomial, in this answer, then we get answer 12. Okay, and the next question is what? Find f of 3. The sub question in that question is what? Find f of 3. So f of 3 is what? Substitute x is equal to 3, and by using this formula fx is equal to, we can also find f of 5, f of 6, f of 7, f of minus 1, and any number, f of 0.5, f of 0.6, we can find by using this formula. So f of 3 is 9 by substituting x is equal to 3. So next problem, again on the Lagrange's interpolation formula, the question is what? Obtain the roots of fx is equal to 0, the polynomial fx is equal to 0, using Lagrange's interpolation formula for the given data. So this is the given data. F of 30 is minus 30. That is, the values of x are what? 30, 34, 38, 42. These are the values of x. So this data is given in this form, not given in the table form. So in the previous example, the data given in the table form, x and y. The first row is x, the second row is y. So if we can write these values in the form of table, then what is the first row? What are the values of x? 30, 34, 38, 42. And what are the values of y or fx? The minus 30, minus 13, 3 and 18. That is the second row in the table. So the value of x and value of y or fx are given. So again, what are the x0, x1, x2, x3? This is x0, this is x1, this is x2, 38 and 42 is what? X3. So again, the x values of x are 4 in number. Similarly, the values of y or fx are 4 in number. So this is f of x0, f of x0. This is f of x1. This is f of x2 and this is f of x3. So start the notation from x0, that is x0, x1, x2, x3, and then f of x0, f of x1, f of x2, f of x3. And we have to first find the polynomial which fits to this data, which takes the values, these values, 30, that minus 30, minus 13, 3, 18. So we have to find the polynomial which takes these values or fit to this data. So write the Lagrange's interpolation formula. This is the Lagrange's interpolation formula. Again, same like previous problem. 4 values are given, and so we have the 4 terms, and substitute the value of x as x in this formula. Substitute x is equal to x, and substitute all the remaining values, that is x0, x1, x2, x3, f of x0, f of x1, f of x2, f of x3, and calculate. We have this answer. So this is the polynomial which takes these values or which fits to the given data. That is, if we substitute x is equal to 30 in this answer, in this polynomial, then we get minus 30 answer. If we substitute x is equal to 34, then we get answer minus 13. If we substitute x is equal to 38, then we get the answer. If we substitute 3, and if we substitute x is equal to 42 in this answer, in this polynomial, then we get the answer 18. So this is the polynomial which fits to this given data, which takes the given values. And then the next question is obtain the roots of that polynomial. Fx is equal to 0. So take f this is equal to 0, fx is equal to 0. So minus 1 by 32 shifted to right side. So 0 into that is 0. So we have this polynomial, and obtain its roots by using either calculator or by using the formula x is equal to minus b plus minus root b square divided by 2a, or we can obtain the, this answer by using calculator. So this is the quadratic equation. What is the formula? X is equal to minus b plus minus root b square minus 4ac divided by 2a. So we have two answers. By taking plus sign, we have this answer. By taking minus sign, we have this answer. And these are the roots of the required equation fx is equal to 0. The next question, find polynomial fx using the Lagrange's interpolation formula for the following data. Also find f of 3. So again, the same type problem. The values of x are given in 4 in numbers, and so write x0, x1, x2, x3 as these values of x, and the values of y or fx are these 2, 3, 12 and 147, and then write the Lagrange's interpolation formula that contains 4 terms. RHS of Lagrange's interpolation formula contains 4 terms, and substitute the value of x is equal to x and all the remaining values of x0, x1, x2, x3, x4, not x4, x3 up to x3, and f of x0, f of x1, f of x2, f of x3. This is f of x1, f of x0. This is f of x0. This is f of x1, x2. So these are the value x0, x1, x2, x3, f of x0, f of x1, f of x2, f of x3. So and substitute the values, we get this answer. This is the polynomial which fits to this data. If we substitute x is equal to 0, we get the answer 2. If we substitute x is equal to 1 in this polynomial, then we get answer 3. If we substitute x is equal to 2, then we get answer 12. If we substitute 5, we get answer 147. So we can tally your answer by using substituting these values, at least 2 values from the table, and tally your answer. Then question is find f of 3. So f of 3 is what? 2 and 5, between 2 and 5, and the answer is 35. So 35, what is the values of y or fx? Going increasing. So the value at 3 must be greater than 12 and less than 147. So it is 35 and it's matched in the table. So we can gauge the answer. So the answer is, the 3 number is nearest to 2. That's why the answer is nearest to 12 but greater than 12. And next problem, again the fitting of polynomial problem, that is find a cubic polynomial using Lagrange's formula. Okay, and if this question is only that find cubic polynomial, this is not given, suppose using Lagrange's interpolation formula. So to fit the polynomial, we can use 3 methods, that is Newton's forward interpolation formula, Newton's backward interpolation formula, and Lagrange's interpolation formula. But if the values of x are not equidistant, so what are the values of x in this problem? -2, -1. So the distance between -2 and -1 is what? Is 1. Then -2 and 2, the distance is 3, and the distance between 2 and 3 is 1. That means the values of x are not equidistant. And so if here using Lagrange's interpolation formula, this statement is suppose not given in the problem, then also we have to use Lagrange's interpolation formula for this problem. So just question is find cubic polynomial which fit to the following data. That is, this is not given using Lagrange's interpolation formula. Then also we have to use Lagrange's interpolation formula, because we cannot use Newton's forward and Newton's backward interpolation formula for this problem, because the values of x are not equidistant. If the values of x are equidistant, then we use either Newton's forward, Newton's backward, or Lagrange's interpolation formula. So this table is given, data is given in the different form, that is in the order pair form. So what are these first values? -2 means x naught, that is the values. These are first place numbers are the values of x, and the second place numbers, the places y places numbers are what? The values of fx or y. And so what are x naught, x1, x2, x3? This is x naught, this is x1, this is x2, this is x3. And these are what? F of x naught, f of x1, f of x2 3, and f of x3. x2 is 3 and f of x3 is 5. So write in proper notations. So this is the given data. So if this data, if you write this data in the table form, then what is the table? That the first row is x, the second row is y, and the first row values of x are what? -2, -1, 2, 3, and the table, the row of y contains the numbers -12, 8, -8, 3, and 5. Okay, so this is given in the order pair form. Then write all the proper notations, that x naught, x1, x2, x3, f of x naught, f of x1, f of x2, f of x3. And then write Lagrange's interpolation formula. Again, the values of x or y are 4 in numbers, and therefore this table contains, this formula contains total 4 terms. These are the 4 terms. So in the first numerator, x minus x naught is deleted. In the second term, what are the term? X minus x1 deleted. In the third term, x minus x2 deleted. This x minus x2, and in the last term, fourth term, x minus x3 deleted. That bracket deleted in the last term. So and substitute all the values. Substitute x as x, because you have to find a polynomial which takes the given values, and therefore substitute x is equal to x. And then substitute all the values of x0, x1, x2, x3, f of x0, f of x1, f of x2, f of x3, we get this answer. Okay, and this is the polynomial which fits to the given data. If we substitute x is equal to -2 in this answer, in this polynomial, then we get answer -12. If we substitute -1 in this polynomial, we get answer -8. If we substitute x is equal to 2, then we get this answer 3. And if we substitute x is equal to 3 in this polynomial, we get answer 5. Sometimes the answer, if you substitute suppose x is equal to 2, then answer may or may not be 3. That is, it may be nearest number to 3. If we substitute x is equal to 2, or if we substitute x is equal to -1, suppose if you substitute x is equal to -1, then answer is sometimes answer may be not equal to -8. It may be another number, but that number must be what, nearest to -8. So the number answer is nearest to -8. If it is not equal to -8, then check that it is nearest to -8. If you substitute x is equal to 3, if the answer is not 3, but the answer is what, nearest to 3. So this is the tally the question, the answer by using substituting the values, at least 2 values. Suppose substitute x is equal to 2 and find the answer. If substitute x is equal to 3 and then check the answer, it is 5 or nearest to 5, number nearest to 5, and therefore your answer is right then. And then find f of 0. The question is find f of 0. So f of 0 is what? By using substituting x is equal to 0, we get this answer, -39/10. So these are the problems of fitting of polynomial by using Lagrange's interpolation formula. Then the next problem is what? The next problem is, from the following data, the values of y are consecutive terms of which 23.6 is the sixth term. So this is the sixth term. 23.6 is the consecutive terms of which 23.6 is the sixth term. This 23.3 is the sixth term. Actually, if we observe the table, then 23.6 is what? Is the fourth number term. 1, 2, 3, 4. But what is this? This table is not given fully that what is the number of this term is the sixth number in the table. And then find the first and 10th term of this table or series. What we have to find? We have to find the first term. So this is the sixth term, means this is the fifth term. This is the fourth number term. This is the third number term. So what is the second term? 2 and its corresponding value. And what is the first term? 1 and its corresponding value of y. That is, we have to find the value of y at 1, at x is equal to 1. We have to find the first term, means what? We have to find the value of y or fx if x is 1, and we have to find the 10th term, means what? We have to find the value of y or fx at 10. That is the problem of interpolation, and here the values of x are equidistant. That's why we can use Newton's forward, Newton's backward, or Lagrange's interpolation formula. It depends on you. But if the values are equidistant, then my suggestion is that use Newton's forward or Newton's backward. And out of these two, if the values of x are equidistant, and if you have to interpolate near the beginning of table, that is interpolating at 1, that is the value of finding y corresponding to 1, means we have to interpolate at 1, and 1 is what? At the beginning of the table, and therefore if you had to interpolate beginning the table, then use Newton's forward interpolation formula. And if we have to interpolate the end of the table, at the end of the table, that is here we have to interpolate at 10, then use the Newton's backward interpolation formula. So when we use the Newton's forward interpolation formula and backward interpolation formula, both the formulas are used if the values of x are equidistant. If the values are not equidistant of x, then use Lagrange's interpolation formula. But if the values are equidistant, the values of x are equidistant, and if we had to interpolate at the beginning of table, then use Newton's forward interpolation formula. And if the values of x are equidistant and we have to interpolate at the end of the table, then use Newton's backward interpolation formula. So here we have to interpolate at 1 and 10. So to interpolate at 1, that is to find the value of y or fx at x is equal to 1, we are going to use Newton's forward interpolation formula. And to interpolate at 10, we are going to use Newton's backward interpolation formula. So first we will find the value of y or fx at x is equal to 1. That is the first term of this series or table. Okay, and so we have to use the Newton's forward interpolation formula. That's why I prepare the forward difference table. And so this is the forward difference table. That is the first row, first column is the values of x, and the second column, in the second column there are the values of y. Okay, and so these values of x are in 7 numbers, and that's why the last column of the table is delta raised to 7 y. But if at any stage, if we all the entries in the columns are same, then no need to find further columns. Here the entries in this third column are what? Are constants, are same, and that's therefore no need to find the further entries in the columns, or no need to find the further columns of the table. So what is the first column? The values of x, the values of y, and then write delta y, delta square y, delta cube y, and so on. So what is delta y? Write either y or notation fx. Here y or fx, any notation we can write here, that delta fx, delta square fx, and so on. If we are convenience for the notation fx, then use the notation fx. And then delta fx is what? This minus this, 8.4 minus 4.8. This is delta y naught, or delta f of x naught. This is y naught means f of x naught. And then this minus this at this place, this minus this at this place. And so we know how to prepare the forward difference table. So this minus this is at this place, this minus this at this place, 3.5 minus 3 is 0.5, 4.5 minus 3.5 is 0.5, 4.5 minus 4 is 0.5. So no need to find the further terms. If you find the further terms, further columns, then all the entries in that columns are 0. And then we are going to use the Newton's forward difference interpolation formula. So in the forward interpolation formula, the first point is important. This is what? A. Here is the notation x naught. We can write A in our notation. So convert this problem in our notation. Write A. A means first point is 3. Then H is what? 3, 4, 5, 6. Common difference is 1. And X, that is we have to find the value at 1. We have to find the first term means what? We have to find the value of y or fx at 1. Therefore, x is 1. And u, right here, instead of p, write u. What is u? Formula for u, x minus a divided by h. So x minus x is 1. A means first term is 3 divided by 1. That is minus 2. We have the answer minus 2. And then write the Newton's forward difference interpolation formula. So this is in different notations. We can write this formula in our notation, that f of x is equal to f of a plus u delta f of a plus u minus 1 by 2 factorial delta square f of a, right? in that form. While writing this problem, answer of this problem in your notebook, write this formula in our notation, that is f of x is equal to f of a plus u f of delta f of a u minus 1 by 2 factorial delta square f of a, and substitute the values. So what is f of a? F of a is 4.8. So right here 4.8. Then what is u? U is minus 2. Then what is f of delta f of a? There is the term delta f of a is what? This is delta f of a. So these terms are, this is delta square f of a, delta cube f of a. So substitute all these values and we get this answer 3.1. So this is what the first term, that is the value of y or fx corresponds to 1. What is the answer? 3.1, f of 1. That is the value of y or f of x corresponds to 1. Then we have to find the f of 10. So we will find f of 10 by using Newton's backward interpolation formula, because we had to interpolate at the end of the table. So again prepare the backward interpolation, backward difference table. No need to prepare the backward difference table, but because we know that only this delta is replaced by del. All the entries in the tables are same, and these values are important if you are going to use to forward interpolation formula, but we are going to use the backward interpolation formula, so these values are important. So this is a plus nh, last value. This is f of a plus nh. This is f of del f of a plus nh. This is delta square f of a plus nh. This is delta cube, not delta, del cube f of a plus nh, and all the remaining are 0. So write backward difference interpolation formula, backward interpolation formula. So again here, while writing in this answer of this problem in notebook, write this formula in our notation. That is what is our notation? Fx is equal to, first term is what? F of a plus nh, u del f of a plus nh, u plus 1 by 2 factorial del square f of a plus nh, and all the remaining terms. And what is a plus nh? That is last term is 9. The last value of x is 9. So a plus nh is 9. Then x is 10. That is we have to find the value at 10. And h is what? Common difference is 1. And then find u as x minus a plus nh. That is bracket a plus nh. That is last point. X is 10. Last point is 9 divided by h is 1. So u is 1. And then substitute, write all the values. That is f of 10 is equal to, this is f of a plus nh. F of a plus nh is what? This is f of a plus nh, 73.9. Then write u, that is 1. Then del of f of a plus nh. So this is del of f of a plus nh, 21.1 right here. Then u, that is 1 plus, and u plus 1 divided by 2 factorial del square f of a plus nh is what? 4.5. Then next term u plus 1 u plus 2 divided by 3 factorial, substitute u as 1, del cube f of a plus nh is what? What is del cube f of a plus nh? Is 0.5, and all the remaining terms are 0, and we have the answer 100. So this is the 10th term of this table. So what is the first term? 3.1 is the first term, and 100 is the 10th term. So if we observe, after 9, what is the value of y or fx? For 10, the value is 100. So these are some problems on Newton's forward, Newton's backward, and Lagrange's interpolation formula. We will discuss the remaining problems on these 3 methods in the next lecture.